Hi folks, welcome. I've been asked by a couple of people to talk about how to align an FM radio, and I'm going to start though with suite generators. These are not laboratory grade. These are probably a hobbyist grade. Might have been used in a repair shop of some kind. This particular one is an EICO 369. We're also going to talk about a Wavetek and a Heathkit, and I'll put those near the end of the video so we can watch those. The first connection that I want to talk about is called the RF out. This connection is the one that the waveform comes out of that is injected into the radio. The waveform can be attenuated with this control. You can do some fine attenuation with this control. The width of the sweep from where this is at the center of the sweep, the width of that sweep is controlled with this control. And that pretty well takes care of the RF out. So the RF out, you can control the attenuation, you can control the center sweep, and you can control the width of that sweep. All of these controls. And this one has the most controls involved with it. But when you send the signal out to the radio, you're going to want to bring a signal back in, and that's what the DMOD is. The DMOD connection comes in downstream in the radio, whereas the RF would be put in the front end of the radio, let's say at the mixer tube. This one would come in at the end of the RF string or right beyond the detector. On this particular suite generator, it does have the ability to adjust the size of the signal that's going into it. But once this goes into the EICO 369, it's mixed with a marker signal, and that marker generator is controlled by this control, and these are the coarse controls for the marker. You can make the marker smaller, or you can make it much larger using this control. This particular one has an additional feature. If you leave this off, or even if you want to turn it on, you can add a crystal, and it will inject it as well, or by itself. And that's what I have in here now, a 10.7 megahertz crystal. Let me pull that out and we'll talk about that in just a moment. You might find it interesting. These crystals are a bit expensive in this particular kind of housing. What I did was I bought a housing like this off of eBay for about 99 cents. I pulled the crystal out, the spring and all the stuff that was in there, just to reveal these pins. And I then bought a circuit board style quartz crystal, and I soldered it to these two pins after cutting out some of this area to allow this cap to go back on. And it works great. So it does a really good job, and it only cost me about $4 or $5 to do that. The other connections that are on the EICO 369, and it's also on the other two, is you have the ability to bring the scope connections in. And this particular connector, I'll remove it so you can see what it looks like, is two pins, and it takes care of channel 1, channel 2, but actually it is the X and Y axis. And we're going to talk about that in just a moment when we discuss the oscilloscope. But that signal, it has two purposes. One, the X pin is sending 60 hertz back out onto the line into channel 1, and that keeps a continuous sweep going. The other one is the DMOD in plus the marker signal that's sent out to the scope, and we'll talk about those in a little bit more detail in just a moment. I've added a couple of other connections. I have an ability to put a frequency counter on it so that I can know exactly how much my marker is. I've also added a a place to turn off the blinking. I'll show that in just a moment what I mean by that, but when the sweep goes across, it actually does a blinking so you don't wind up with a double image, and I'll show how that works. I don't ever use either of these two, particularly after I've gotten the 10.7 megahertz crystal. I really have no need to know exactly where my frequency is up here. Okay folks, I have the oscilloscope connected now to the EICO 369 up above here, and what I've done is I've taken the EICO and I've got it on a crude detector circuit. So I have the signal being injected in here, going through a diode and a resistor, and I'm filtering a little bit through these two capacitors, and then coming out through the DMOD in, and then the DMOD is sending my signal out to the scope. So let's talk a little bit about the oscilloscope itself. The oscilloscope has several modes of operation. One of those modes is called XY, which is what this particular scope is in. Different oscilloscopes will use different methods to do that. I have two other oscilloscopes and both are totally different. The normal mode of operation is I'm up here in either the A or the B, and those in turn will allow this control to operate. Okay folks, right now I have got the EICO hooked up to a simple circuit. That circuit that I have it hooked up to is simply a diode going through a resistor and then back to the DMOD in. The grounds go through a couple of capacitors there. This comes out of the EICO manual, and it's their design for a detector circuit. I have a couple of these that I use. Now this is the oscilloscope looking at channel 1 and channel 2 in their native way. This signal right here is the 60 hertz signal that's just continuous. This one right here is the actual waveform that is adjusted by the frequency and RF level and so forth. I'll move the RF level up and down and you can see how that one wiggles. Alright, what I'm going to do is we're going to go to another mode of operation, and I don't mean to be too basic for folks, but be honest, I didn't understand this when I first started, so it's better to give too much information than not enough. But this oscilloscope has several different modes of operation, but one of them is called XY mode. The mode we're looking at right now is what we're used to seeing, and the way these waveforms are being swept, it's based on when the waveform rises, is the setting I have it in right now. It will shoot a it'll do a sweep across the oscilloscope. Well, what if we were to keep a continuous sweep going, let's say at 60 hertz at all times, and we would put that in on this channel 1, on this channel 1, which is the x-axis, and I'll do that now by simply pressing this button, and what we see now is we see a waveform being produced that is the result of sweeping that little crystal circuit. Now, because I've got a channel 1 also being read at the same time, it's giving me some erroneous information, so we'll turn off channel 1, and we're only interested in looking at channel 2. Channel 1 is continuously sweeping back and forth at 60 hertz. Channel 2, or the y-axis, is what's coming across, sweeping that diode and resistor, and then resetting and then coming back. Okay, I'm going to open this up just a little bit. You want your x-axis to go from one side of the screen to the other, so I'll do that by adjusting channel 1, or the x-axis, and that opens it up nicely. For the most part, what we're looking at a signal that has no resonance as it goes across. It's a continual amount of voltage, and then it comes back across. I'll also turn the blanking off for just a moment so you can kind of see. See, we no longer blank. We're just going back and forth across that same signal. Of course, that's meaningless to you. So let me give you something to base that on. I'm going to turn the 10.7 megahertz marker on, we'll make an adjustment, get that marker up where we can see it. Alright, I've got the marker now right in the middle, and we can see the marker nice and big. That's 10.7 megahertz. What I'm going to do now is I'm going to turn the blanking off, just to give you an idea what the blanking does. We're going to see a signal here, and we'll see another signal on this line as a result. My phase is out a little bit on this one. These two should line up on top of each other, but this is a good point of illustration for you to see what that blanking does. I normally keep the blanking on. I have no reason to particularly turn it off. But we're looking now at a circuit that will allow all frequencies to pass, and it's not affected by 10.7 megahertz. Let's look at another circuit in this next shot. I'll set up for it, and I'll be right back. Now, keeping everything the same, I've now hooked up another circuit. This time, we're seeing that we do have a resonance peak as the signal comes across. It zeros, comes back, and then repeats. I'm going to lower that down just a little bit so that we can see it a little bit better. And I want to increase the waveform size, lower it a little bit more. What I've simply done is I've now hooked the same rig up to a IF can from a transistor radio. This is a 10.7 megahertz IF can. Notice where my marker signal is. It's right in the center where we want it. And let me show you how that works. I'm going to adjust this can, and we're going to make this can be out of adjustment. So you see the marker now falling off the side. Okay, the 10.7 hasn't changed, but we moved where that can now resonates. Now I can move back the other way, and that's as far as I can go there, but you can get the point. So if I have a signal coming out of a mixer that's at 10.7 megahertz, I'll get the most signal through right at 10.7 megahertz. I can broaden the sweep a little, or I can open up the sweep just a little bit. We can look a little bit closer at this particular signal. I'm going to have to make a couple adjustments. Now you see we're not exactly right on. What I'm doing is I'm reducing the sweep, which makes us get closer and closer to this signal. Now if I really want to fine tune this, what I can do now is I can attempt to make more adjustments. Now it should be right in the center of that, and now I'm going to get a broader sweep, and we'll make another slight adjustment. But this is how the system works as a whole. So we made a mini IF section is what we've done with this. Okay, the next thing that we want to do is we want to hook up to a radio, and we want to see what the results of sending a signal through a radio does. What we're going to do is I have a Zenith radio sitting over here on the bench, and I'm going to connect in to the mixer side per the manufacturer's directions, and I'm going to inject a signal all the way through all the IF cans, but I'm going to take the signal back off before it goes through the detector itself. Okay, let me set up for that, and I'll be right back. Okay, in this video shot, the instructions had me hook up right here at the mixer tube, and this is to pin 1, which is right inside of there. I've got a nice convenient place that I found to hook up to. The other side that it wants me to remove the signal from is right up here at V5, and it's a grid going into V5, and it's before it goes through the detector stages. The objective here is to adjust the cans over here on this side in order to produce the highest signal that we can produce here. I've already got the scope set up, and let me move the camera a little bit. Excuse me for tapping the camera there for a second. And I'm going to try to carefully move this radio around. This radio is actually working, so I want to move this around, and according to the directions, to adjust cans 9, 10, 11, 12, and 13 to get the largest waveform that I can get. So I'm going to go to can 9 first, and I've got a tool here that I'm going to stick into that can, and notice the waveform as I begin adjusting, and you can see the waveform getting bigger. Okay, I'm going to try to get that waveform a little more onto the screen, and I've got the marker now right in the middle, and that's really looking nice. So I actually improved that one, even though the radio was working. I'm going to go into 10 next and see if we can make some improvements. And do notice the marker signal is right here. I don't know if you can see that glittering. I'll make it big for just a second. So there it is. Nice little bow tie looking thing. I'm adjusting the sweep width is what I did. Alright, now I'm going to adjust 10, and we'll see if we can make some improvements on that. Not much, maybe a little. Okay, now I'm going to go to 11. And I'm inserting my tool into 11. Now we're going to adjust it. Oh, I got a little bit out of it. And the marker's still the same. Now I think it wants me to go to 12 and 13. So I'm going to go to 12. I'm really not getting a lot out of 12. Let's go into 13. 13 I'm getting a lot out of. Alright, we're nice and centered. Okay, folks, what we've done now is we've taken the entire IF string and we have adjusted it so that the signal is maximum going all the way through from the antenna all the way in. So just to clarify what I've done, I've made adjustments to 9 and 10, adjustments to 12 and 13, and adjustments to 11 as well, in order to allow the signal all the way through to this point. Now at this point we want to make an adjustment to 14 and 15, and we have to hook up to a different place. So I've got to set up, and I'll be right back. Okay guys, once again we're still injecting the signal early on into the mixer, and from the mixer we're coming all the way through. This time we're going to go through the limiter tube, and we're going to go through cans 14 and 15 and a tube they call the discriminator, which is simply a double diode. And where I'm going to hook up this time is at point B, which is right out of that diode, and what I'm going to get is something that looks similar to an S-curve. Now what the procedure wants me to do is to adjust 14 and 15 to get as close to a S-curve as possible. And I'm picking up a little bit of interference here. There we go. And I'm going to stick my tool in. I'm going to make an adjustment to 14 first. Notice how the S-curve kind of looks the best there. What we would like to see is as straight of a line as possible right here. And notice it bellies right there. It tucks in here. And right about there it's fairly straight. Now I'm going to go to 15. I'm going to adjust it as well. And I'm trying to do the same thing. I want to get that marker as close to the middle as I can. and I think I've kind of achieved that now. From this point, this radio will play, and I'm going to set up for the next shot, and we'll see how the radio sounds at this point. Okay, I have the radio now hooked up to the antenna. Let's see what it sounds like now. I'm going to, I just simply hooked it up, and it was already sitting on near a station. That sounds pretty good. Let's dial on through. That sounds pretty good, doesn't it? Now, this station is really hard to get that I'm coming to next. I think I've done a pretty good job. That station's very hard to get. Now I'm going to come in on a strong Chattanooga station. Well, that sounds pretty good. There's another Chattanooga station. Sounds pretty good. And guys, I live down in a pretty good hole. I have problems picking up radio stations, and I'm very pleased with how this is picking up now. Okay guys, in the next setup I'm going to connect the other two signal generators up one at a time, and we'll see how they look as far as the output onto this particular radio. We've seen now what the EICO 369 looks like. Let's see what the other ones look like. Okay, in this shot I have the Wavetek 1080 hooked up. I currently have all the frequencies down about as low as I can go. This Wavetek will go much higher in frequency than what's needed for an FM radio. I have the sweep rate going to the horizontal set at line, which is 60 Hertz. You have two other choices with it. I also have got the sweep width down about as low as I can go, and I'll play with that a little bit when we get onto the scope. I've also brought in the external marker. I don't really care for the markers that are with the Wavetek. They give me a choice of 100, 10, and 1. And frankly, sometimes, like with this radio, I have a little bit of trouble seeing those. The controls for it are right here. You can do a wide to a narrow, but you can also adjust the size of it as well. And let me bring this into the camera view so that you can see what this looks like. So I'm going to sweep over. Let me adjust the camera down. Alright, as you see again, we have a nice S-curve like we set up before, and I'm going to increase that marker size, which is somewhere over in here, and I'm going to adjust the marker. You can start seeing it moving. I don't know if you can see that or not on the camera, but I'm going to move it. It's coming up, coming over, and now you see it right here. I'm going to go back down, and it's somewhere in this area here, which puts me right at about 10.7 megahertz on my Lodestar signal generator that I'm injecting externally into the Wavetek. So the Wavetek is very similar in how it acts. I still prefer the EICO, but let's do the next camera shot, and we'll use it, and we'll set up the Heatkit. Okay, now I have the Heathkit IG-57A hooked up. This one's a little bit different. It's different in the fact that back here is where the RF out is, and they call it the sweep out. And the signal, though, is hooked up still the same way. I'm hooking it up at the front end of the radio, and then I'm picking my signal back out and going into what's called the trace input. I've labeled it D-mod so that I can kind of keep everything the same. This one also has an external marker that can be put in. The way the scope hooks up is a little bit different. It uses these banana jacks, but then it uses a BNC here. The way that the marker signals work on this, it's got all these switches across here. These are all different markers. And let's see what the marker looks like. I'm going to go ahead and turn on the 10.7. And I'm going to increase that marker size for you all to see. Let me tilt the camera down so you can see everything. And I think you can see that marker right there. I want to increase it, and I'll decrease it. And also notice that I can turn on the 100 kilohertz marker, and you'll see a little blip right up in this area come on. And there'll be one down in here. So that's showing the bandwidth. I've got 100 on each side. Let me increase that size just a little bit more so that maybe we can actually see those. I'm going to turn that 100 off again, so we should see this blip go away. There's the blip. So we're looking at about 100 and 100, and looks to me like we have a nice waveform set up here. Another S curve. This one, you know, again, these are not laboratory grade, so they're going to be off a little bit. So as I promised, we've now looked at the EICO 369, how to inject the signal into an FM radio and to adjust it. We've also looked at the Wavetek 1080 and how its connections worked as compared to the EICO, and then we looked at the Heatkit. Now I'm going to be honest with you, on both of these two, it's been a while since I've used them, and it took a good bit of messing with it. Let me show you what I ran into with the Heatkit that caused me so much confusion. I could not find the marker signal the first time that I did this, and let me show you what happened. I'm going to increase the sweep width of this. Notice that there's another curve here, and another one, 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 and they just keep on going. Well, the way that I found it is I turned on the 4.08 marker, and I just happened to see that mark come across on one of these while I was dialing. Maybe we'll see it again. Turn off the 10.7. Okay. But you can get kind of lost when you're doing one of these, and it's important that you're on the right harmonic. They don't necessarily have those harmonics built out like they should, and so it's not always obvious. I do frankly find this is a little bit of an art form, particularly with this one, since it's such a broad sweeping one. Now I've just turned on the 10.7 megahertz marker. Notice that we don't see it on this particular curve, so we're going to have to adjust the sweep center until we find it. So see how many of these curves we create? And there's the one that we're looking for, and that's the 10.7 megahertz. All right. If you've got any comments, I would love to see them at the bottom. Anything that you can add to this to help someone in the future use one of these non-laboratory grade type sweep generators. But I will enjoy seeing your comments. This is my first YouTube video. I'm sorry for some of the roughness of it. And I'm going to tell you this. These folks that do these YouTube videos, there's a lot of hard work that goes behind the scenes. So enough for now, and thank you, and goodbye.